Let's start with what is data science, and this is actually a complete course. So I am starting this webinar. This is the free webinar, and if you want to join the complete course named as Data Science Expert program that is offered by elearners365.com. Please let me ensure that this my screen share is visible to you. Is it visible?
Yes, ma'am.
Okay, thank you. So the complete program is 2 years program where we have flexible learning hours and will include many real world projects. Those are taught and mentored by highly qualified mentors and industry experts. So what is eLearners 365, which is offering this course? So this is an online platform and with the vision to spread knowledge and wisdom along with practical exposure to help students, scholars, and professionals to upgrade their skills during the changing needs of rapid digitalization. So, in this scenario, many people are nowadays trying to get some job which is enthusiastic, which will actually every day provide them some enthusiastic feeling to work upon. So, data science is one of that field, and in this field, you have to work upon with many techniques and tools which we have studied throughout our journey. So this is a small introduction of myself. You may also see the description and you can also check my blog which I've gave you in the chat section. So you can explore many blogs in there. So currently I'm working as ML architect with a company called mobileprogramming.com and also pursuing my doctoral degree in computer science and engineering. Okay, so let's proceed further. So if you are a fresher and want to become a data scientist, then really this webinar and the course will help you. This is the trend of data science in today's scenario. So you see that this is the blue graph that is quite started from a very low level and approaching the highest, right? So in India or over the world, this data science field is actually spreading with a lot of people. People are actually trying to get a job in this field and they're actually trying to learn what is data science and how they can apply this practice to the coming problems related to any domain, whether it is manufacturing, healthcare, education, finance, so any domain, right? Okay, so let's proceed further from here. So basically, the complete course include the basics of Python as well as R and hands-on experience with frameworks like Keras, TensorFlow, and PyTorch. So we will also see the glimpse of all these things in our upcoming webinars. So you can also, if you want to join this course or refer this course to anyone, we can also share the brochure with you. So this is the complete roadmap which we are going to follow uh, while learning data science. So here we need to learn following things to become a good expert in this field, that is mathematics. So if the fundamentals of linear algebra like um, basic dot product, that is also very helpful thing which we study in our a ninth or 10th standard. The dot product means matrix multiplication of two matrices. You can think of how that dot product is very useful in very recent applications of data science and artificial intelligence. Let me give you an example of it. So if you have two matrices, right, and you are performing the dot product, In each matrix, you have rows and columns, right? So when we actually multiply two matrices, we multiply the row of one matrix with the column of another matrix, right? So you can think about these are two vectors which you are multiplying, right? So this matrix will leading you to the calculus thing. So we are multiplying two vectors, right? And these two vectors having their magnitude as well as direction, right? So when we have both the things, magnitude and direction, we can plot these vectors on xy plane. And when we plot them, actually, there is an angle between them which is actually giving us more meaningful insights when we see how similar these two vectors are, right? Means if their direction is mostly the same, then we see that those vectors are quite similar, and if their magnitude also differs by a little value, those vectors are quite similar. So from here we can see that this is a area of this is a concept of cosine similarity, right? So how that dot product leading us to cosine similarity. Now if you can think about multiplying the same matrix by itself, right? And you can think about a matrix can be an image, a matrix can be a signal, a matrix can be, uh, you might think about this as a vectors, actually rows and columns of some numbers. So we can also extract these numbers from data which is written in English or in any other language. So we can extract the matrix of features from image as well as from document or a text, from signals, from any other modality we can think about, right? So there are various deep learning concepts which actually play a significant role to extract features from the data. What are features actually? So features are the prominent thing which we see in an image, in sound, signal, or in any other modality, right? So let me see, there is someone else who's trying to join. Okay. So if we will calculate the self similarity matrix by just doing the matrix multiplication of the same matrix with itself, we will get some numbers. And you can think about multiplying the same image by itself. That image can be a part of a video. So there are multiple frames in a video, right? So if you multiply each frame with one of the other frames available in the video, that is called the matrix you will get after multiplying that. Let's say you have 10 frames in a video, so you'll multiply 10 frames with itself, means first with other 10, second with other 10, third with other 10, and also itself. So you'll get a 10 cross 10 matrix. And this 10 cross 10 matrix will give you the understanding of how many frames are similar to each other. So you can think about an application where you want to provide the repeated number of frames, the events which are happening repeatedly in a video, right? So this is one application where a very fundamental concept of linear algebra is being used in a very important real world application. So this is helpful in a surveillance video, right? So in surveillance video, we actually don't want to capture the repeated frames. We want to capture the distinguished frames, right? So when we got the repeated frames, we can subtract those things to get the distinguished frames, right? And also, mostly in security applications, this is quite helpful, right? So this is one domain and one application of basic linear algebra that is useful in very recent application and very important application. So the detailed understanding of linear algebra is very important. There are other important concepts which we'll cover, such as eigenvalues and eigenvectors, right? How these are very important concepts and they play a significant role in understanding the principal component analysis, right? So these are the things which will include. Other than this, we'll include probability. Give me a second. Someone is trying to join. Okay. So probability is actually where we will understand the basic concepts of conditional probability, joint probability distribution, what is normal distribution, right? Normal distribution is something which is present in every natural activity, right? So if we draw a repetition of some activity, maybe thousand or more number of times, we will get a bell-shaped curve. And that is the curve which fits and gives you many important understanding of what is the mean of that activity, how many times that happened, what is the standard deviation. So we'll cover all these very small concepts which play a very important role while we work upon the data which is very large nowadays, right? So in the beginning of internet, there was very small data. So Excel sheets provided by Microsoft or other companies was enough to handle that data. But nowadays, data is exploring with a fast speed. Data is everywhere. We have sheets, we have data in the form of images, sound, signals, other modalities. And what computer understands is just numbers that don't understand your signals or sound or image or anything. So for it, everything is a number. So if everything is a number, that can be dealt with only mathematics or probability or something, some basic techniques which we have been studying since our childhood, right? And the ways to handle that data is programming languages. So Python is the one which we'll cover in the course, as well as the basics of R also, which provide many built-in functions and recipes to apply on that data. Then here comes statistics. So in the statistics, there are some hypothesis text testing. What is a random sample? Because many times we need to create some random matrix, and that can be created using NumPy, or there are the functions available with pandas as well. So we'll cover that. And hypothesis testing is very important concept. Let me give you an example of hypothesis testing. So in in a scenario, let's say you want to build an application where you have some training images. Those training images are very high quality images, maybe captured from DSLR or something, some very high definition camera. You built a model, you built some piece of software which can actually recognize the images or recognize the person in the image, recognize the disease present on the face of a person. So you can think about any acne related or any other health issues that is present on the skin of a face, skin of the person, maybe on the face skin, and that that piece of software which we'll call model is able to assess that on very high quality data. Now you built an application of that and you released your app, your your Android app, or you might create a iOS app which is using the functionality of that small piece of software you built, the model, and you released it between among the people, right? Now people are testing and they're uploading their selfies from their mobile camera. Now, you might think about your piece of software and the model should work on that, but you might see in practicality that is not performing very well on the real time data. Why it is so? Because you have trained the model on DSLR images, but you're testing it on not very good quality images that are captured from mobile phones. The quality of the image is got reduced, so your model is not able to identify where is the disease present on the face, or where is the object present. A small object might be there, so sometimes this model won't work for the small things which are present in the image on the at the inference time, at the real time. So we need to actually do some testing before applying these images, these real-time images to our model. We need to assess that what is the quality of the image which we are actually trying to judge, how it is different from your original training data. If the quality of the image is not very good, you might prompt to the user that your image quality is not up to the mark. If you'll prompt that, the user have this understanding that okay, my camera might not be taking that good picture so that this model can perform. But if you'll present the wrong results, that will actually give a very wrong idea to the person. So there we have to use some hypothesis testing, right? So you can here also you can check how similar these two images are in terms of their patterns, in terms of their textures, right? So some algorithms which we study in digital image processing, like watershed algorithm is one of those. Some advanced techniques in computer vision, like um, there is some functions for image similarity assessment, right? There are some functions which can see the difference between two images available with OpenCV, that is computer vision library. So we'll cover OpenCV as well. Also, you can build your customized way of assessing. There are ANOVA test, right? ANOVA is very important test which helps you to differentiate between two different distributions, whether they are same or not. There is T test, two sample T test. That is a special case of ANOVA test that we can perform. There are BRISC scores, BRISQUE, this is the name of the score, which actually helps to find out how similar two things are, right? So there are fundamental concepts of statistics as well as the concepts of regression and correlation, which we need to understand in detail to become an expert in this field. Other than this, because we get the data in many forms, so we should have the basic understanding of SQL, means DBMS. Okay, so we know how we should know how to run queries, basic queries of fetching the data, right? How we can get the customized rows and the columns from data which is present in the database, right? How we can connect with it so that we can utilize that data, right? Next, here comes, other than that, we should know programming that I have already included. Then here comes machine learning. So in machine learning, basic thing is model building. Model is nothing, is just piece of a software which is actually which is actually built on the concepts of mathematics, statistics, probability, right? So whatever we do with pen and paper in our initial days of learning from 9 to 12th standard, we actually study many concepts related to probability, statistics, and some advanced concepts we need, also linear algebra we need to cover here to become a good data scientist, right? So using everything that we study in mathematics, and we apply we mix the programming skills with it and create a piece of a software that we call a model. That's nothing big actually. And what is underfitting and overfitting is actually checking that model is how much your data is able to fit with that model. Fit is something which we need to see by example. What is fit? A best fit, good fit, bad fit, right? Generalization, how the things actually falls at their own places when we apply our own model on it and see how the data is actually going to fit with our needs. Then there are some advanced techniques which are getting used in industry as well as in the practices. That is ensemble methods. Ensemble means the methods which combine many techniques to provide some results. You can combine, let's say, um, decision trees, random forest, XGBoost, and other techniques. Five, six techniques you actually merge and create an ensemble version of it. And each each technique is actually performing is our its best to provide you the prediction. Right? All the advantages of the related techniques you use in the ensemble method. Then here comes deep learning. The remember the features I was talking about is related with deep learning. It is a technique which can it is a technique which can actually extract the features, right? Like when you can think about if you are born in 90s or so, you can think about a negative of a picture. We initially, when we were childs, we were having a film, a black film that is captured while we capture a photograph, and we see black and white pictures of ourselves. There are no colors in that. So a feature is something like that. If you want to feel what does a feature look like, so feature is something like that. When you listen some melody, some sound, and you keep on you do not remember the lyrics, actually you do not remember the complete sound, but you remember few sections of that melody which you used to sing within yourself, and you remember some things. Those are the features, those are the important features available with that sound, right? So this way you can feel what is the feature. I'm not telling you in mathematical way or in a technical way what are features, but these are things which you can understand while you do that mathematics and more understanding of the data, right? So deep learning is a field which actually helps you to work on any modality, but you don't need to build mathematical models, right? So here we will use neural network that is inspired by our brain, and actually there are small units which are connected together and basically give you an understanding of the complete data. Whether that data is an Excel sheet, whether that data is an image, or it can be a sound, it can be a signal, anything. This is the input of that neural network. And what is the output? That can be something like whether this image belongs to this particular category, the whole image, or if, let me take the example of a image where there is a scenery, there are mountains, there are rivers, there are people are riding. So that kind of scenery is captured, a very peace scene. So it can provide this classification that this is a scenery, this is a indoor image. Let's say two categories. This is outdoor and indoor, right? And other applications of the same neural network with some modification gives you where everything is located. So one is what, another is where. It means in the where you'll get the location. So that is the concept and the idea behind object localization and object detection. You can locate and get a boundary around every object, that this is a person, this is a car, mountain, or river, or boat, or tree, anything. So, with some changes with that model, we can use the same image to get the answer of where every object is located, right? Then there comes segmentation. Segmentation means how the foreground and background pixels are actually differ to each other. That is segmentation, right? So if you want to segment only the people present in the complete scenery, you don't want to use the concept of classification. You want to use the concept of segmentation. It means you want to segment the foreground pixels with the background pixels, right? So with the some changes with that deep learning model, you can use the same image for segmentation purpose. You can extract the people present in the image, right? Now let's see and go to more detail of it. And now you want to see whether that person is having is wearing mask, or having this wearing cap, or maybe wearing the life jacket if they are actually near some lake or something, or not. So that is actually after segmentation, you are looking for detection, right? So these concepts actually requires few changes with that deep learning model and give you a better picture in the output, right? So this is a very challenging, very innovative and enthusiastic field which enthralls you every day to work upon these concepts, right? So that is deep learning. For deep learning, you need to provide more data, a lot of data, because computer is a machine. A model you've been creating as a machine is a piece of software. It doesn't have any experience like we have, like human have. So it requires a lot more data to understand the scene. So the more data we provide, the more processing power we provide, it will give the best results, right? So that is actually deep learning. This we will cover in more detail, right? Then here comes the small concepts and different domains of it. So one is feature engineering. So I already told you the feel of what is the feature actually, right? So if you think about a text, or you maybe think about a news or something. So feature in a news article. What is a feature in the news article, right? So basically, the feature are the words present in there, and we actually create a dictionary with ourselves to create features related to the words, right? There are words, and there might be some words or sentences which are linked to each other, right? So initially we talk in terms of noun, and then we start using pronouns, and then we use conjunctions to relate those words. So this is basic form of a paragraph I'm talking about. So there are ways which can capture these relationships, whether we have talked about the same thing in the previous line or not. What are the different names we have been using? So that is called named entity recognition, right? You have already heard about semantic analysis, right? Segmentation is different. That is used in computer vision, where semantic sentiment analysis is very different from that. So sentiment analysis is something which is understanding the sentiment of a complete paragraph, whether it's a good or a bad, right? What kind of sentiment is present in the complete paragraph? So for that, we need to do feature engineering. And features are actually numbers. It is no text involved in there. It is actually a number. So what we are doing in this natural language processing, we are converting each word to a number, right? So there are the concepts of one hot encoders, label encoding, word to vec concepts, word to vector. That is the concept I'm talking about. Globe is one of the concept which is the advanced thing to create features from natural language processing, right? So what we are doing overall is, from any modality, we are converting a matrix. We are converting it to a matrix of numbers, and then we work upon that matrix. We can think about that matrix as vector. We can think means a collection of vector. We can think about that matrix as a simple matrix fundamental and can do matrix operation on it. And at the time of result, we understand what matrix is actually showing and convert that to a description, right? So this is the whole pipeline and whole understanding behind any application of this data science project or machine learning project or problem solving, right? Then there comes some visualization tools. So only if you learned Excel, that is very important and very significant data visualization tool, and other tools also like Tableau, Power BI. So these are very important tools, and they give you more easy way to do things. There are no not complex things, right? So if there is some person who is who is from some other domain and want to learn data science, and he is not proficient very much with these these programming languages, or but the person is familiar with the concepts of mathematics and how to choose something from a pile of data, so they can use Tableau, Power BI, Excel, these tools to plot the data and to see what are the significant insights of that data. Then let's say we have knowledge of everything, but we don't know how to actually present our our findings to the person, to the people, right? So for that, deployment is also very important. How we can deploy our model so that it is flexible, scalable, and available to the people 24 cross 7, right? So for that, we need to understand what are the deployment options, right? So here comes a field which require the understanding of cloud platforms. Why cloud? Because those actually work on pay as you go, right, model. You only pay for the resources you are using. Resources can be a very high configuration machine which we require to train a deep learning model, right? So we can rent a machine there, which we call a virtual machine, and we can work upon that machine. The training requires a lot more resources, but when your training is complete, you can save your model within the KBs, within KB size, right? Then you can download that model from there, and the small little kilobyte file you can upload anywhere, which can be used for the testing, right? And if you are thinking that you might have more hits on that small model, so you can put that file in cloud somewhere. So cloud can be your, in Azure we call them virtual machines. In AWS, Amazon Web Services, we call them elastic clusters, EC2, right? And in Google Cloud platforms, we call them machines only, right? So those virtual machines are useful to develop something, to deploy something so that people can use it. Person who are sitting anywhere in the world can use some way, can use that model, can do some inferencing on it, can predict some results out of it, right? So deployment is something like that. And if a person don't know anything, don't know the programming from the scratch, but he should or she should have the basic understanding of how the process goes, what is the life cycle of data science, which we'll govern in the coming sessions. So there are some automation tools available. You can build drag and drop pipelines. Those are available with cloud platforms, right? You can just drag data and then you can drag which model you want to build. If you don't know the detail of that model, that's fine, but you can test it out. You can work upon it. Then you can see how you can split and how you can predict things. So the whole pipeline is available, how you can create the pipeline. The tutorials are available with Microsoft Azure as well as AWS as well as Google Cloud Platform. So the certification in these fields are really very important to get a very good job with high pay scale. And yes, last but not the least is case studies and the projects you might want to work upon. So this is the complete roadmap we have actually covered, emphasizing every field, every concept which is required to become a data scientist, right? So if you have any doubts, please ask me now. If there are any doubts how to study these concepts, from where you can study, some resources, anything, case studies or projects, you can ask me. Is there any? Okay.
No, ma'am, no doubt.
Okay, thank you. So basically, this is the these are all the fields for them for means we should know at least the basics. If you are not very proficient with all the concept, you should be proficient with some of them related to every field. So these are different domains. You can become data scientist also when you have already worked with Excel sheets with the data which is categorical, which is ordinal, right? Which we see in an Excel sheet. We can a very simple way, right? You can also become a data scientist when you work only with images, computer vision domain. You can also will get a good job in the field of data scientist if you are good with natural language processing. You worked on any modality, on any text modality, right? So You can practice one of these to become a data scientist. You don't have to practice all. If you have worked with all, I don't know how much salary you'll get, right? That would be a very huge number. So in India, this field is really exploding nowadays. People are this a booming field, and you'll get, even if you have a very little experience, with some of the projects which you have done uh, just by learning from online resources, you'll get a good job. But for that, what happens when there is a teacher and when there is only YouTube? There is a difference. First thing, sometimes you lack in punctuality, you lack in reading that stuff every day. If you're punctual, if you're persistent, YouTube is enough. And also, you need to actually consult many places to get the answer of your queries. But when there is a mentor, you can ask the queries. And also, you'll have more uh, question answer kind of conversation. But in Google, you have to type everything, and sometimes you get distracted by multiple links and things, right? So that's why mentoring is also very important when you work on things, right? So both ways you can study and become a good data scientist, and you can search on Google. There are a lot more jobs available with um, this data science, right? So I think this is it for today's session, and there is a feedback form I'll share with the people who have joined this call. So please send your email IDs so that I'll share a feedback form for this session, and that will actually encourage me for the further upcoming webinars. So you can share your email ID in the chat section, and also if you want to get the recording of this session, that might be available on your email IDs. So I'll send the recording link as well, so you can play and understand and see the concepts anytime. So please write your email IDs in the chat box. Okay. Thank you so much for joining the session, and I'll be hoping that every one of you will be present in the next session. Thank you.